Hello friends, in this AV we are going to talk about the first exercise numericals of the third chapter of class 10 physics, that is machines. We will take up the important numericals of exercise 3A. The first question here says a crowbar of length 120 centimeter has its fulcrum situated at a distance of 20 centimeter from the load. We have to calculate the mechanical advantage of the crowbar. Now here I'm not going to talk about the formulas that we are going to use. I have just written them for you. You may just go through it once. So for the first question here, they have given us the total length of the crowbar, that is 120 centimeter. The load arm is 20 centimeter and effort arm will be total length minus the load arm, that is 120 minus 20, that is 100 centimeter. So using the formula for mechanical advantage, that is equal to effort arm divided by load arm. We have the value of effort arm, we have the value of load arm. We just put the value 100 by 20 and we get the answer as 5. The second question says a pair of scissors has its blades 15 centimeter long while its handles are 7.5 centimeter long. What is its mechanical advantage, that is MA. Now here what we have to do is we will again be using the same formula, MA is equal to effort arm by load arm. Here they have told us that the effort arm is 7.5 centimeter, load arm is 15 centimeter. So we just put the value 7.5 divided by 15 and we get the answer as 0.5. The mechanical advantage is a ratio, that is why we do not have any unit. Now let's look at question number 3. It says a force of 5 kgf is required to cut a metal sheet. A shear used for cutting the metal sheet has its blades 5 centimeter long while its handles are 10 centimeter long. Now what effort is needed to cut the sheet? Again, using the same formula for mechanical advantage is equal to load divided by effort, we can find out the effort. Here the effort arm is 10 centimeter and load arm is 5 centimeter. So the total load also they have given to us, that is 5 kgf. So let's find it out. So the effort arm is 10 centimeter, load arm is 5 centimeter. So mechanical advantage would be effort arm by load arm, that is 10 by 5, we get it as 2. Now the load is 5 kgf. So we know that mechanical advantage is load divided by effort. So you can check this in the formula also where I had shown in the beginning of this AV. So effort is equal to, from that formula of mechanical advantage, we are just interchanging the position of effort and mechanical advantage. So effort is equal to load upon mechanical advantage. Load has been given to us and mechanical advantage we have calculated to be 2. So 5 divided by 2, the effort required is 2.5 kgf. Now let's take a look at question number 4. It says the figure below shows a lever in use. This is the figure they have given. To which class of lever does it belong? Now here the fulcrum lies between the load and the effort. That means it belongs to class 1 type of lever. The next question is if AB is 1 meter, AB is 1 meter, the total length is 1 meter, AF is 0.4 meter, find its mechanical advantage. Again we can find it out using the same formula. The total length is 1 and AF is 0.4. So this is going to be FB or BF is going to be 0.6 meters. And after finding the mechanical advantage we have to calculate the value of E. So here given is AB is equal to 1 meter, AF is equal to 0.4 meter. So we calculate BF or FB, that is 1, that is the total length, minus the given length, that is 0.4. So we get it as 0.6 meters. Mechanical advantage would be BF divided by AF. So 0.6 upon 0.4, and we get the answer as 1.5. No unit because this is a ratio. Now the second part of the question, the third part of the question asks us to find the effort. So load is equal to 15 kgf. Here they have shown in the figure. Now effort is equal to load divided by mechanical advantage. So load is 15 divided by 1.5. We get it as 10 kgf. Effort required is 10 kgf. Let's talk about question number 5 now. It says a man uses a crowbar of length 1.5 meter to raise a load of 75 kgf by putting a sharp edge below the bar at a distance of 1 meter from his hand. We have to draw the diagram of the arrangement showing the fulcrum, load and effort with their direction. State the kind of lever. Calculate the load arm, effort arm, mechanical advantage and effort needed. This will again be a class 1 type of lever. You can just draw the diagram from the book. I'll be showing you only the calculation part. So here the total length of the crowbar is 1.5 meter. It's given to us. Effort arm is 1 meter. So load arm will be total minus the effort arm. That is 1.5 minus 1, that is 0.5 meter. So effort arm is equal to 1 meter, which we have to calculate for number 2. It's already here. So mechanical advantage is going to be effort arm upon load arm. We have the value of effort arm. We have calculated the value of load arm. So 1 divided by 0.5, that is 2. And finally we have to calculate the effort required. So we know that effort is equal to load upon mechanical advantage. So that is equal to 75 divided by 2, that is 37.5 kgf. Let's take a look at the next question, that is question number 6. It says a pair of scissors is used to cut a piece of cloth by keeping it at a distance of 8.0 centimeter. So load arm is 8 centimeter from its rivet and applying an effort of 10 kgf by fingers at a distance of 2 centimeter, 2.0 or 2 centimeter. So effort arm is 2 centimeter from the rivet. We have to find the mechanical advantage of the scissor, the load offered by the cloth. So here the second part of the question says, how does the pair of scissors act, as a force multiplier or as a speed multiplier? Now after calculating the value of mechanical advantage only, we will come to know whether it acts as a force multiplier or speed multiplier. So let's get started. So here the effort arm is 2 centimeter, the load arm is 8 centimeter, effort is 10 kgf. So mechanical advantage is effort arm divided by load arm, that is 2 divided by 8, you get 0.25. Now load is equal to MA multiplied by effort, that is the value of MA has been calculated as 0.25 multiplied by 10, that is the effort from here, and we get the answer for the load, that is 2.5 kgf. Now we have calculated the mechanical advantage MA. So the pair of scissors acts as a speed multiplier. Why? Because MA is less than 1. I hope this is clear. Now question number 9 is also important. Let's take a look. It says the figure below shows a lever in use, and first of all we have to find out to which class of lever does it belong. So we look for the fulcrum. It's not lying between the load and effort, so this will be a class 2 type of lever. Then we have to calculate if FA is 80 centimeter, this distance is 80, AB is 20 centimeter, this is 20, that means total length is 100 centimeter. We have to find the mechanical advantage and we have to calculate the value of effort. So here FA is 80 centimeter, AB is AB is 20 centimeter. So BF or FB will be the sum of both of these, that is 80 plus 20, 100 centimeter. So mechanical advantage is the total divided by AF, that is 80. So 100 by 80, we get it as 1.25. Now effort is calculated as load upon MA. We have the value of load 5 kgf divided by the value of MA, that is mechanical advantage, we have already calculated as 1.25. So 5 divided by 1.25, we get the answer as 4 kgf. The next question, question number 10 says, the figure below shows a wheelbarrow of mass 15 kg carrying a load of 30 kgf. So the total load will be 30 plus 15 with its center of gravity at A. They have already shown it in the figure. The point B and C are the center of wheel and tip of the handle such that the horizontal distance AB is 20 centimeter and AC is 40 centimeter. Now we have to calculate the load arm, the effort arm, the mechanical advantage and the minimum effort required to keep the leg just off the ground. So the load arm is AB, that is 20 centimeter. The effort arm is AC, that is 60 centimeter. So MA is effort arm upon load arm. So effort arm is 60 divided by the load arm, that is 20. So we get the answer as 3. Then we have to calculate the total load. Total load will be 30 plus 15, that is 45 kgf. This we are going to use to calculate the effort, because effort is equal to load upon mechanical advantage. So load is the total load, that is 30 plus 15, 45 kgf divided by the mechanical advantage that we have calculated, 3. So we get the answer as 15 kgf. Now question number 11 says, figure 3.19 below shows the use of a lever. Now we have to state the principle of moments as applied to the above lever. To which class of lever does it belong? We have to give an example and of this class of lever, and this is going to be a class 3 lever. You can give any example from the class 3 lever which we will be talking about. And finally we have to calculate the, if FA is 10, they have given us this distance to be 10, AB is 490, this is 490, so 490 plus 10, the total length is 500 centimeter. We have to calculate the mechanical advantage, the minimum effort which will be required to lift the load, 50 Newton. Now if you remember, for class 3 type of lever, the fulcrum and the load are at two ends and the effort will lie somewhere in between. So based on that definition, this will be a class 3 lever. Example can be a sugar ton or a spade lifting a load or a knife, for example. These are all the examples of class 3 type of lever. Now we check the third part of the question. Here the first part says we have to state the principle of moment. So that is nothing but the moment of load about the fulcrum is equal to the moment of effort about the fulcrum. Okay, so arm length of the load multiplied by load is equal to arm length of the effort multiplied by the effort. This is the principle. Now coming to the numerical part, FA is 10, AB is 490. So the total length BF will be 100. Now mechanical advantage is AF or FA upon BF. So that is equal to 10 divided by 500. So we get it as 1 by 50. We are not calculating it because in the answer also they have left it like this. Then effort is equal to load upon MA. So we have the load 50 Newton divided by MA is 1 upon 50. So 50 will go up. So 50 multiplied by 50, it comes out to be 2500 Newton. And finally the last question of this exercise. A fire tongs has its arm 20 centimeter long. It is used to lift a coal of weight 1.5 kgf by applying an effort at a distance 15 centimeter from the fulcrum. We have to find the mechanical advantage of the fire tongs and the effort needed. So here This is what they have given to us. The fire tongue has its arm 20 centimeter. Effort arm is 15 centimeter and load arm is 20 centimeter. So mechanical advantage is effort arm divided by load arm. So 15 divided by 20, we get the answer as 0.75, and the effort is calculated as load divided by MA, that is mechanical advantage. So we have calculated the mechanical advantage here. Load is given to us, that is 1.5. So we write 1.5 divided by 0.75. This is a simple calculation and we get the answer as 2 kgf. That's all we have in this AV for you. Happy learning. God bless.